Hello everyone, welcome to our channel 2bits. In this video, we are going to solve some previous year DBMS questions which were asked in the InfyTQ exam. Now those who are new to this channel, let me tell you that this is our 8th video on the InfyTQ series, and in previous videos we have discussed many questions on Python and some previous year questions. So let's start with the first question. In this question, we are given a relation and some functional dependencies, and we need to tell what is the highest normal form of the following relation. So let's start with the question. The question says that service num is our candidate key. If the candidate key is not given, we need to find out the candidate key, but in this question, we are given with the candidate key. So this is our first functional dependency and this is our second functional dependency. Now let's check out what is the highest form for this relation. So firstly, we will check out if the relation is in BCNF or not. So the condition for BCNF is that the left hand side should be a super key. LHS is super key. If this condition satisfies, then the following relation will be in BCNF. So let's check out if the following relation is in BCNF or not. So a relation to be in BCNF, both the dependencies must be in BCNF form. Now as service num is our candidate key, it will be a super key, as all candidate keys are super keys. So this relation is in BCNF, as LHS is a super key. Now for the second functional dependency, we see that vehicle type is not a super key. So second functional dependency is not in BCNF. Now let's check for 3NF if our relation is in 3NF or not. For 3NF, we know that there should be no transitive dependency. And by transitive dependency, we mean that no non-prime attribute should determine a non-prime attribute. So if a non-prime attribute determines a non-prime attribute, then that means we have a transitive dependency. So prime attributes are attributes that come in our candidate keys. If there were more candidate keys, then we would have more prime attributes. So here our prime attribute would be service num, and rest of the attributes will come under non-prime attributes. Now this is our prime attribute and all of these are non-prime attributes. Now for checking 3NF, we need to also check that if LHS is a super key or RHS is prime attribute. Now if any of this condition satisfies, then that means our relation is in 3NF. So let's check for both the functional dependencies if these are in 3NF or not. So as we know, service num is our candidate key, and as it is a candidate key, it will also be a super key. So now we can see that in the first functional dependency, our LHS is a super key, so it will be in 3NF, and it will also be in 3NF as it was in BCNF. So if the higher normal form is satisfied, then the lower normal form will also be satisfied. Now let's check for the second functional dependency. In second functional dependency, we see that LHS is not a super key and RHS is a non-prime attribute, as service charge is in the non-prime attribute. So both of these conditions are not satisfied here. So that means this functional dependency is not in 3NF. So as one of the functional dependencies is not in 3NF, then the relation cannot be in 3NF. Now let's check for 2NF. For a relation to be in 2NF, we know that there should be no partial dependency. And how do we check for partial dependency? We need to check that any proper subset of candidate key should not determine a non-prime attribute. If this condition is satisfied, then there would be no partial dependency. So what do we need to check? That a proper subset of candidate key should not determine a non-prime attribute. Now what do we mean by proper subset? Suppose AB is a candidate key, then A and B both will be proper subset of this candidate key. Now proper subset of A would be phi, as we cannot divide any further, and phi is always included in the subset. Now let's check what are the proper subset of our candidate key that is given here. So our candidate key is service num, as it is only one attribute and we cannot divide it any further, so only phi will be our proper subset. So there is no proper subset of this particular candidate key. So as there is no proper subset, so both the relation will satisfy the 2NF form. Service num is already a candidate key and vehicle type is not the proper subset of our candidate key. So both these relations satisfy the 2NF property. So answer here is the relation is in 2NF form. So let's move on to the next question. So let's start with this question. In this question we are given two tables, a customer table and an order table, and we need to tell what customer details will be fetched after execution of this particular query. Now let's try to execute this query. So we are said that select c.customer_id and customer name. So output should consist of customer ID and customer name from orders O, customer C. Now the comma will create a Cartesian product for the two tables where c.customer_id is equal to o.customer_id. So this is our table C and this is our table O. We need to find those rows where o.customer_id, for example C103, is equal to c.customer_id. Here we find 103 in the second row. So this particular row and this particular row will be joined together. And from the order date, we consider only the month part, and that month should be equal to April. So first we check in the orders table, as order date is in the order table, so we check which rows have the month as April. So these are the two rows that have the month as April, and here we have another and amount should be equal to the result given after this execution of the subquery. So this is a subquery and the result from this subquery will go into the amount. So let's see what is the result of this particular query. So it says that select minimum amount from orders. So here we have our orders table and here we can see the amount value. So the minimum amount here is 199.99. There are two rows which have minimum as their amount. So the amount that we get as the result of our subquery is 199.99. So in short, what the query says is we need to find those rows where c.customer_id is equal to o.customer_id and the order date in which the month is April and the amount is 199.99. So we see that we have one row in which the month is April and amount is 199.99. So we need to join this particular row with the row in the customer table which has the ID as C105. So where we find C105, we find it in this particular row. So this particular row will be joined with the last row, and from that we need to fetch the customer ID and the customer name. So customer ID will be C105 and customer name as given here is Tony. So the customer whose detail will be fetched is Tony. So Tony will be the answer to this question. Now let's move on to the next question. So in this question we are given an employee table and we are given an output and we need to determine which query among the following options will give us this particular output. So let's start with the first option. So first option says that select e.empid. So in our result we need empid, emp name, m.empid, that will be referred as manager id, and m.amp name, that will be referred as manager name. So these will be the four columns that will be present in our output. From employee A, inner join employee M on e.empid equals to m.manager. So here we are referencing the same table as E and M, and we are saying that we need to join this table on e.empid equals to m.manager. So we need to check that where our e.empid is equal to m.manager id. So let's suppose our emp id is 921. So we need to check particular column in m.manager where the value is 921. So here we find a match. So this row will be joined with our first row of the E table. Remember that this is the same table just by referencing with E and M. Now we need to join rows in this manner. We need to check simultaneously that E.salary should be greater than or equal to 35,000. So let's check which rows have salary greater than equal to 35,000. So let's start with the first row. Here e.empid is 921. So let's find a row in the M table with manager as 921. So here we find this row. Now let's check whether the salary, whether e.salary, we need to check salary in the E table, whether e.salary is greater than equal to 35,000. So is the salary in this particular row greater than 35,000? Yes. So this row will be included in our answer. So in our answer, we will include e.empid. So e.empid was 921. e.emp name in the first row was Xavier. m.empid. So m.empid in this particular row was 925, and m.emp name, and m.emp name in this particular row was Susan. This will be the first row of our output. Now let's check out for the next row. So in the next row we have e.empid as 922. Now let's check out in the M table where our m.manager is equal to 922. So the first row with m.manager as 922 is this row. Now we will check if e.salary is greater than 35,000. Yes, it is greater than 35,000. So we will include this particular row in our output. So here again we know that e.empid is 922. e.emp name is William. Now m.empid in this particular row is 923, and m.emp name in this particular row is Alice. So this will be our second row in the output. Now we also had another row in this M table where m.manager was equal to 922. So this row will also be included in the answer. Now for the next row in the result, we know that e.emp id is 922, e.emp name is William, m.emp id for this particular row is 924, and m.emp name here is Robert. Now let's check out for the next emp id, that is 923. Now we will check whether we have any row with 923 as m.manager. So there is no row with value 923 in m.manager. We cannot include this in our result. Now let's check out for 924. Similarly, there is no row for 924 in m.manager. And for 925, we also do not have any row in m.manager. So this will be our result for our first option. So does this result match with the result given in our output? No, it does not match. So the first option is not correct, and you also do not need to find out the complete result. You can simply check that this first row doesn't match to the first row in our output. So we know that this will not be the correct option. So let's check our B option. In B option, it says that select e.empid, e.emp name, m.emp id, m.emp name from employee inner join employee m on m.emp id is equals to e.manager where. Now check here where m.emp id is null. Now we can clearly see that there is no row in emp id which is null. So this particular option will give no result. So this cannot be the correct option. And similarly in the C option, here the where condition is same as m.emp id is null. Again, we do not have any row in the emp id column that is null. So it cannot be our correct answer. Now, as we are left with only the D option, so we know that this particular option is our correct answer. Let me know in the comment section whether by executing this query you're getting this particular answer or not. So this will be your task. Thank you for watching. Please like the video and subscribe to our channel as it motivates us to create more such content for you.